Hey guys, we're going to look at lesson 1.5. This is the final lesson of chapter 1, unit 1, and we're going to talk about some special angle pairs today. We have a couple definitions that we're going to cover. The first, we're going to look at some adjacent angles, and the definition is two coplanar angles with a common side and vertex and no common interior points. We're going to take a look at the diagram in the bottom left. So here I have two pictures. And in the first picture, on the left, we're going to compare angles 1 and 2. Angle 1 covers this section. Angle 2 is going to cover this bottom section. Here, the side that they share is this side that's sort of between the two. They share a vertex as well. And the two green sections, they do not overlap, meaning they have no common interior points. So angles 1 and 2 would be an example of adjacent angles. And you want to think of adjacent angles as they are right beside each other. In our next example, if we compare the two sections, we have DOG, which is the hole here that I've been referring to, and angle 3 is this bottom right section. So here, the side that they share is actually along the bottom of our picture. They share a vertex. Now the issue that we have with this one is the two sections overlap, meaning they have interior points that are shared, which makes these non-adjacent. Okay, they are not beside each other. Actually, we have an angle inside of a larger angle. So these would not be considered adjacent angles, even though they share a common side and vertex. They do share common interior points, which goes against our definition. Next, we have some vertical angles that we're going to be looking at. Vertical angles are two angles whose sides are opposite rays. And here we're thinking, I want you to think of straight lines. Okay, we're thinking straight lines here. So in our first example, under vertical, we're going to look at angles 4 and 5. What we have here, we have two lines that intersect, meaning we have opposite rays. So angle 4 are the sides. Here, angle 5 sides. And those opposite rays form a straight line. So here we have a good example of vertical angles. Now, if we look at our next example with angle 6 and 7, angle 6, here are our sides. Angle 7, we have the two sides. Now, we do have a straight line when we compare these two sides of our angles. However, the issue is with our other pair of sides. Those are not a straight line. They're not opposite rays. So angle 6 and 7 would not be an example of vertical angles. Even though they're across from each other, those sides aren't forming straight lines. All right, moving on to our next two terms. Here we're going to look at complementary and supplementary angles. And these are two terms you may be familiar with from last year or some of your previous math classes. We're going to look at them a little bit more in depth. Complementary angles, they are two angles whose sum is 90. And supplementary angles there are two angles whose sum is 180 degrees. So we're going to look at complementary and explore that for just a moment. Here we have a set of adjacent angles, and let's put in some measurements here. Let's say this angle is 40 degrees, this angle is 50 degrees. And then we're also going to draw another set of angles, but this time we're going to separate them. These are not going to be adjacent. So in both diagrams here, we have a 40 degree and a 50 degree angle. Now, a lot of times when we're looking at complementary, people assume that they always have to be adjacent. Well, the definition never mentions the word adjacent. It just says the sum has to be 90. And here, that sum is 90 degrees, as well as in our second diagram, that sum is 90 degrees. These are both considered complementary, even though in our second diagram they're not adjacent. As long as their sum is 90, then we have complementary angles. And this is true for supplementary as well in the 180 degrees. Now, a way to remember that complementary is a sum of 90 and supplementary is a sum of 180, I have two different tricks. First, complementary starts with a C, supplementary starts with a S. With complementary, you can change that C and make it into a 90. Supplementary, you can change that S to a 180. And now you know complementary is 90, supplementary is 180. So that's one little trick. Another trick that I use is sort of C comes before S in the alphabet. 90 comes before 180 on a number line. And there we can sort of C and 90, S and 180, they have that same relationship. So those are two little tricks to help you pair up the degree with the correct term. Our next three terms, we have a linear pair, and we'll go through these one at a time. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So down here we have two angles. All right, we'll call this angle 1 and 2. So these two angles, they are adjacent. They share this common side. And their non-common sides, which would be here and here, they form a straight line. They are opposite rays. So this would check the boxes for linear pair definition. Next, we have perpendicular. These are lines, segments, and rays that form right angles. And here you can see the symbol for perpendicular is looks like an upside down T. And a lot of times in our diagrams when we see perpendicular, we will either see that symbol or you can even see a box which indicates this is a right angle. In our next definition, we have an angle bisector. And this is a ray that divides an angle into two congruent angles. So this is kind of like midpoint. We have a ray that's dividing an angle, and now we have two congruent halves. So with angle bisector, here we have this ray that's dividing this larger angle in half into two congruent parts. So for example, if this section were 30, the other section would also be 30. If the section at the top was 5x, the other section would also be 5x. So they're going to be congruent and have the same measures. what I want you guys to do is pause the video and use this diagram to find a pair and describe each term that we have covered today. All right, so pause that now and spend a couple of minutes and we'll come back together and check. All right, guys, so you have been working on our different terms for section 1.5. Here are just some of the answers. There's definitely more than one answer for each of these terms. Here are some of the answers here that we'll look at. So adjacent angles, here we have AFG and FGE. Biggest thing there we're looking for is a shared side and there's no overlap. For our vertical angles, we have CGB and EGF. So here we're looking for two straight lines and the angles are sort of directly across from one another. Complementary, we're looking for two angles that together make 90 degrees. Here we have AGB and AGF. So those two together would form a right angle. Next, supplementary, we are going to use AGB again and also AGE. So here, supplementary, they do form that straight line. So this is also a linear pair, okay? Linear pair and supplementary sort of go hand in hand. And then finally, perpendicular. Just understand how we would write perpendicular. We have this line CF and BE. They do form a 90-degree angle there. And wrapping this up, we have an angle bisector. I have a lot of colors going on here in my graph, but right here, GD, this ray, is bisecting this top quarter here, this section, and you can see that by these little markers. All right, those little tick marks there. Okay. All right, guys, take a look at your homework. As you have questions, please shoot me an email and get in touch with me. Look forward to hearing from you guys.